Okay, so now we're going to be jumping into expressions and equation, pretty much algebra. That's pretty much where we're at right now. Okay, last unit, this is 10 and 11 together, but really we're going to just focus on a few main things from these chapters that are quite important for algebra. Okay, so expressions and equations, the definitions, they're mathematical sentences that have letters, numbers, and operations. The difference is that equations have an equal sign. So for example, oops, oh, we can't see it. Let me get some color here. So for example, 5x, it's supposed to be a 5, plus 6 equals, let's say, 27. All right, that would be an example of an equation because it has that equals sign. Okay, because it has that equal sign. And an expression would just be 5x plus 6. So that is an equation. That is an expression. No equal sign. Okay. All right, so these should be familiar to you. The formulas that we've been using for area and circumference, those are examples. Sometimes they're expressions and sometimes they become equations. Okay, let's look at the parts. So when you have an actual number in front of a letter, the number is a numerical coefficient. Okay, so this 3 is a numerical coefficient. Okay, the y would be a variable. So it's just a letter that represents a mystery number. Then you have your usual operation sign, and then you have your constants, which are numbers that are all alone. You know exactly what that number is. So numerical coefficients, variable, operation, constants. Okay, and remember, when you have an equal sign, that means both sides are going to result in the same answer. So they're equal. It's an equation. This would be an example of an equation. If we didn't have the equal 7, that would be your expression. So there is a link. There is a video on algebraic expressions. This is the link. You can watch it if you're still like a little bit wonky about how the difference between equations and expressions and the different parts of it. Okay, and you just need to watch it up to 8 minutes and 5 seconds. All right, so ways of showing multiplication. So we talked about already when we show multiplication, we can use the x. That's what you're used to. That's what you've always done. But we also mentioned that you can use a dot. So when we were doing, for example, radius squared, so like the r squared, we also said that it's r times r. Okay. You can also use what is called an asterisk, which is the little star if you're thinking about a keyboard. And you can also use brackets. So when you see brackets like this or brackets like this around both numbers or around only one number, then that means that they're being multiplied together. Okay, so think dot, asterisk, brackets, multiplication. Okay, so let's look at these and make some expressions and equations. Because some of these are expressions, some of these are equations. Equations are what? Have the equal sign. Have an equal sign. So the cups will be variables and the counters will be constants. Okay, the cups are variables, so like the x or y, and the constants will be the actual number. So let's do this first one, A. So how many cups do we have? We have 3 cups. So that becomes, let's use x, 3 x. Okay, and here's our operation here. After the 3, x, 1, 2, 3. And then subtract. How many little counters do we have? 1, 2, 3, 4, 5. Minus 5. Now, is this an expression or an equation? If you said expression, ding, 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 you are correct. Okay, let's go to the next one. Now, how many cups do we have? We have 1 cup. Remember, a cup is a variable, so we could make that even y. And then our operation is addition. And then how many counters do we have there? We have 3. Oh, and we have an equal sign. And we have some more counters. How many counters do we have here? Okay, so y plus 3 equals 7. Now, is this an expression or an equation? If you thought equation, you're correct because it has that equal sign. Okay, let's do, oh, jumped over to C. Let's do B down here. So again, cups are variables, counters are constants. How many cups do we have? We have 1 cup. So we're just going to say, okay, we'll make that one. I kind of like x, using x and y, and we have our addition sign and how many little counters, which are our constants. It's 3. And that one, it doesn't have an equal sign, so it's an equation. Okay, and then the last, D, we have 2 cups, 2x, 1, 2, because remember cups are our variables. And then we're adding in 4 counters, and that's equal to how many counters? 2, 4, 6, 8, 10 counters. And because it has that equal sign, it is an equation. Oops, you know what? I made a mistake on this other one here. Sorry, I was looking ahead. This one over here is actually an expression. Very sorry. Okay, so equal sign, equation, no equal sign, expression. Okay, let's keep going. So we're going to create one. So model each phrase using cups and counters and write each phrase as an expression or an equation. So we want to say that it's 5 more. These are the words that we're using, 5 more than a number. Okay, so if I have some random number and I want to put 5 more of it, and there we go. And that would be our expression. Okay. So B, 3 times a number plus 4 equals 10. Oh, right there. That should tell you what it is. So 3 times a number. So it's something random. 3 times a number, we're going to do 3x, plus 4 equals 10. An equation. Okay. And then 7 equals a number. So 7 equals a number divided by 8. Oh, so a number, it's actually a number divided by 8 equals 7. So you can even read it backwards. 7 equals a number divided by 8. You can even read it that way. Okay, so if we were using cups and counters, because that's what it was asking as well. So if the cups are the unknown and the counters are a constant, if I'm looking at this expression here, I'm going to say, okay, my unknown, I have like a cup, my best cup drawing, plus 5 counters. Okay. The next time, 3 times a number plus 4 equals 10. So here's my random number, like the empty cup. Oops. Plus 4 equals, gonna run out of space here. 1, 2, 3, 4, 5 equals 10. Okay. And then the next one is we have a number, or 7 equals a number. So this is just a number. We don't know what the number is. Number, and it's divided into 8. And that's going to give us 7. Okay. All right, so these are our cups and counters and our expressions. Now, let's look at algebra tiles, because if we were in school, I would have a bunch of algebra tiles for us to kind of manipulate. So when you have an algebra tile, kind of thinking of the cups and the counters, you have the X, this green bar, that represents your unknown, your variables, X. If you have a red square, that's 1. And if you have a white square, that's minus. Okay, so here's an example. So we have how many X's? We have 1, 2, 3. How many counters? We have 2 counters here. And then what's our result here? Because that's an equal sign. 2, 4, 6, 8, 10, 11. So when we look at this and we put it together, this would actually be 3x plus 2, right? Because those little red squares represent plus 1. So there's 2 of them. Plus 2 equals 11. We wouldn't put plus 11. It just equals 11. So 3x plus 2 equals 11. Okay. Now, let's look at these different ones. So how many x's do we have here? We have 1x. How many tiles do we have here? Oh, and they're white, so that represents 1 each. 1, 2, 3. So that's actually minus 3, because there's 3 of them. And it's going to give us 4. Remember, it's positive 4 here. So we have x minus 3 equals 4. Okay, do the next one. We have 2 of these x's. We have 1, 2, 3 of the white ones representing minus 1. So again, minus 3. And that gives us 5. That's positive. We don't need to write the positive. So we have 2x minus 3 gives us equals 5. Okay. All right. Now, hopefully that makes sense. These are your homework workbook pages. All right, these are due Friday, remember? So get them done. If you have any questions, please send an email.